So, dear audience, the topic of my PhD is the role of gut microbiota in cystic fibrosis. My name is Blanka Bódy. My vision is to offer a complication-free life for people with cystic fibrosis by investigating the role of gut microbiota in the disease. So I have two ongoing projects. The first one is the comparison of gut microbiota in cystic fibrosis patients and healthy individuals. Here you can see the gut wall of a healthy individual and a cystic fibrosis patient, as the CFTR channel works just fine in an otherwise healthy individual. It is dysfunctional in a CF patient. It results in several local and systemic complications, including a continuous inflammatory cycle. So our aim was to compare the gut microbiota of CF patients and healthy individuals. We included articles about adults and children as well. Our outcomes were alpha diversity, beta diversity, and the abundance of certain bacteria. This is our search key. We conducted the search in 5 databases. At the end of the first selection process, we ended up with 14 articles and 1 additional article after the search update last August. The outcomes that we could assess quantitatively were 3 alpha diversity indexes and relative abundance. And the qualitative analysis included 2 additional alpha diversity indexes, absolute abundance, and beta diversity. Let's jump to our results. First of all, well, it looks a bit funny, but the first outcome that we could analyze was alpha diversity. It gives us the microbial diversity of one given sample. And there are several indexes that could be used to analyze alpha diversity. Shannon index is one of them. It takes bacterial richness and evenness into consideration as well, ranging from 0 to infinity, with the higher numbers indicating a higher diversity. We analyzed standardized mean differences between the CF and the control group and divided the population to subgroups according to age: infants, children, and adults. If the articles lie on the left side of the line of no effect, it means that CF patients have a less diverse gut microbiota compared to controls. If they lie on the right side, it means that they have an increased microbial diversity compared to controls. So with that in mind, we can see that there was no difference in the subgroup of infants. And children and adults with CF had a significantly less diverse gut microbiota compared to controls. The second index that we could analyze was observed autos with 2 subgroups, children and adults here. And looking at the diamond, we can see that there is a decreasing tendency of alpha diversity in the subgroup of adults. However, this is not mathematically significant, but clinically relevant. The third and last index that we could analyze, I don't know why it looks like this, was SHA1 index. This takes bacterial richness and evenness into consideration as well, putting more weight on evenness. The 2 subgroups were children and adults here. And as the diamond does not cross the line of no effect, we can say that adults with CF have a significantly less diverse gut microbiota compared to controls measured by SHA1 index. After this analysis, we wanted to take a closer look to this subgroup of infants. So we conducted a follow-up analysis of Shannon index in the infant subgroup during the first year of life at 4, 6, and 12 months of age. But the diamonds tell us is a decreasing tendency of alpha diversity in infants with CF during the first year of life. This figure shows the same information. The different colors represent different studies. The striped lines are the control groups, and the straight line is the infants with CF subgroup. So the other outcome that we could quantitatively analyze was the relative abundance of certain bacterial taxa. Relative abundance is a percentage measure. It takes into consideration the percentage that a given bacterial taxon takes up from the whole bacterial community. The two taxa that we could analyze were Bacteroides and Veillonella, both in the infant subgroup. And looking at the diamonds as they crossed the line of no effect, we can say that there was no significant alterations in the abundance of bacterial taxa in people with CF. So the strength of our analysis are that we could analyze age-related differences as well as gut microbiota maturation in people with CF during the first year of life. And we have a higher level of evidence due to overall larger sample size. Our limitations were the high risk of bias of the articles, as well as limited abundance data, and that we could only include articles from high-income countries. All in all, we can say that cystic fibrosis serves as a barrier to the diversification and maturation of gut microbiota. Our implications are mainly for the research field, that therapeutic microbiota modulation should be extensively researched, as well as CF-related factors influence on gut microbiota composition. So we have finished internal review and sent the manuscript for language editing this morning. Thank you for the immediate response, Mahmoud. Our second project is the effect of CFTR modulator therapy on gut microbiota of cystic fibrosis patients. So CF comes with several gastrointestinal manifestations, including dysbiosis. The first core problem is the CFTR gene mutation, which results in insufficient CFTR protein level or function. However, we have a solution for this problem so far, the CFTR modulator therapy, which acts by either increasing the folding of or trafficking of the CFTR protein to the cell surface, or by enhancing the function of the inactive CFTR channels. The second core problem comes from all the other complications of the disease, the high-fat diet, medications, exocrine pancreatic dysfunction, low intestinal pH. They all contribute to an altered microbial community. So our question was, to what extent is modulator therapy effective in resolving dysbiosis? Our aim was to investigate the impact of CFTR modulator therapy on gut microbiota. We included children with CF before modulator therapy and after initiating this therapeutic modality. Our outcomes will be the same: alpha diversity, beta diversity, and the abundance of certain bacteria. Our hypothesis is that dysbiosis is reduced after CFTR modulator therapy. Our source of data was the cystic fibrosis-related pancreatic disorder registry. We finished database filtering and data cleaning, and microbiota analysis is also finished. So now biostatistical analysis is underway. We will analyze the samples of 29 patients at 4 time points: baseline, 6, 12, and 24 months after initiating this therapy. All in all, in my 2 projects, I aim to understand the role of gut microbiota in cystic fibrosis. The quote that I brought today is from Confucius: "The man who moves a mountain begins by carrying away small stones." Thank you.
I have one question for the first presentation, and my question would be, do you have any data in the literature about modulation of the microbiota in CF patients, in pediatrician patients, especially short-chain fatty acids?
Yeah, excellent question, thank you. We read articles about probiotic supplementation, and the result that they could provide with this supplementation. Well, it was not much, but visible. So it is not something that would solve the whole problem, but helps maybe a bit. We also read articles about the amount of short-chain fatty acids in stool samples, but not as a supplementation orally. So there were no articles that I can now think of which did this supplementation modality. Thank you for the question.
Congratulations. I have one question related to your second topic. In the first one, you presented the data about the children younger than 1 year. It was not a significant difference between the compared to the baseline, right? So for me, it suggests that if you use intervention with the CFTR modulator therapy and you use it for 1 year, are you confident that you will get? It's a long enough waiting period to have an effect on the microbiota?
Thank you for the question. So there are several articles investigating this matter. In fact, there are some which are past the 1 year milestone, and they all came to the conclusion that after even some months, so not even a year has to pass, that microbiota is changing for the best. Yeah, so it does not require that much time.
Thank you.
Thank you.
If not, then a second question.
Okay.
Do you know any data about zonulin and occludin in CF patients, which are markers for permeability and tight junctions in the gut barrier?
Well, very good question. Short answer, no. I did not come across any articles that would investigate their role in the disease. Most of the articles focus on the channel.
Feeding type of the infant can influence the microbiome. Did you have any data about the infants? What was the feeding method, breastfeeding or formula feeding for these babies?
Thank you for the question. So many of the articles stated in the infant age group what feeding modality they were on, but none of them analyzed these different groups separately. So they only stated at the baseline characteristics how many infants were breastfed or formula fed or mixed, but they did not give us any data on the separate groups, unfortunately. But that would have been an interesting question to answer.